So we're going to be looking at exoplanets, but we're going to be looking in particular at the methods that we use to detect them. Now the first method is called direct imaging, and this is probably the most basic way of detecting exoplanets. This is simply just using a telescope or some other instrument to view a planet directly. Now, just to be clear with some terminology, exoplanets simply mean planets that are outside of our solar system. Now, this is probably the most basic way of detecting exoplanets, but it does come with some negativities. So one of the weaknesses or disadvantages is that they are difficult to detect using this method. And this is because the star that they're orbiting can outshine the planet. So that means that the light from the sun or the star that is orbiting can just be too bright that you don't even see the small planet. Now, usually if we want to detect these kinds of planets, we have to rely on the fact that it can reflect the light from the star that it's orbiting. Now, another major way of detecting exoplanets is something known as the radial velocity method. Now, you can see I have an exoplanet orbiting a star. Now, this star is going to be emitting EM radiation, and we can actually receive spectral lines of this star. Now, as a planet orbits this star, what it's going to do is it's going to cause a Doppler effect in the spectral lines. Now, at point 1, the planet is moving towards the Earth, and therefore it will cause a blue shift in the received spectral lines. At point 2, the planet is moving away, so we get a red shift. Now, this Doppler effect is going to be very, very subtle, but just about measurable, and that's how we can detect an exoplanet. Now, one major disadvantage or weakness to the radial velocity method is that you need a massive planet. So planets around the same size as the Earth will struggle to produce a significant Doppler effect. So you need a planet with a large mass in order to have a measurable effect. And this is because it's the gravitational field of that planet that is causing this Doppler effect. And we know that in order to have a greater or a stronger gravitational field, you need a heavier planet. Another weakness is that you need an edge on orbit. And that means that the planet and the star have to be orbiting in line with your view from Earth. So that at one point the planet is moving towards you and at another point it is moving away. Now the third method is something called the transit method. And this is where the exoplanet blocks some of the light received from the star that it's orbiting. So here this black shaded in object is my exoplanet. And as this planet passes in front of the star, you can clearly see that there's going to be some sort of blockage from this area that it's covering. So the light received from that area of the star is now going to be blocked. So if you were measuring the amount of light received from the star, it would look something like this. Now what you'll see is that in this light curve, there is a dip as a result of this planet. And the way to determine that this is an exoplanet is that these will be regular dips. So you'll see continuous dips occurring at certain time intervals. And what's actually useful with this method is using the amount of time it takes, you can actually be able to work out the radius of the orbit. And also the depth of this dip corresponds to the radius of your exoplanet. Now one big weakness is that you need a large planet again. But this time it's more so the size of the planet. You need a bigger planet if you want to see a big enough dip. You also need a very short orbital period. And the reason for that is if your orbital period is too long, you won't be able to notice regular dips in the light curve of the star. If your orbital period is short enough, you can regularly measure and you could regularly be able to see that there is a dip in the light curve. Otherwise, you can't actually be sure that whatever is causing this dip in the light curve is actually an exoplanet orbiting that star. It could simply be another object or just some random fluctuation in the star. And once again, it's ideal to have an edge on orbit. And that's because you can get more blockage from the start.
Now, the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously, go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.